Carl Friedrich Gauss is sometimes referred to as the greatest mathematician since antiquity. There's a story about Gauss in early elementary school. Gauss was always finishing his math work early, so his teacher, in an attempt to keep him busy, asked him to add up the numbers from 1 to 100. Gauss took 2 steps back to his desk, turned around, and gave the correct sum of 5,050. It turns out there is a shortcut that can be used as follows. Consider writing the sum twice, like this. Because in each equation, the left side is equal to the right side, we know that the sum of the left sides, 2s, will be equal to the sum of the right sides, which will be 100 pairs of 101, or 100 times 101. So 2s is equal to 100 times 101. We can divide both sides by 2, and we get s is equal to 50 times 101, or 5,050. Now, use Gauss's method in a calculator to add up all the integers between 1 and 264. Pause the video and then hit play once you have a sum. You should have calculated a sum of 34,980. You can use Gauss's trick to find any sum where the numbers increase or decrease by the same amount. This is because the sums of the pairs will always be the same. We cannot use Gauss's method if the pairs do not always add up to the same sum. Consider the sum shown here. For adding up the terms of a sequence where consecutive terms have the same ratio, we use the following method as described by Euclid. To find this sum, instead of writing the sum in the reverse order, we multiply the sum by the common ratio. We then subtract the first equation from the second equation to get 3 times the sum is equal to 4 to the 5th minus 1. Notice that conveniently, all of the middle terms cancel out. We can then divide both sides of the equation by 3 and find that the sum has the value of 341. Use Euclid's method in a calculator to find the following sum. Pause the video and then hit play once you have a sum. You should have found the sum to be 21,523,360. Next time I see you in class, you will be tasked with finding the sums of sequences with a common difference and sequences with a common ratio. Please be sure that you are comfortable with using both Gauss's and Euclid's method. See you in class.